Hi, GOR. This is an explanation of the Lesson 5 homework answers. So please try these before you watch the video. And then if you got any wrong, you can fast forward it to that question. Or if you want to watch the whole video, you could rewind the video, whatever you need to do to make sure that you understand it. So there were two rules that we learned yesterday, and one of them have to deal with question 1 and 2, and that is a tangent line. So this line right here, XY, is called a tangent line. It intersects a circle in one spot. And a tangent and a radius will be perpendicular at the point of tangency. So question 1 wants us to determine if XY is a tangent line. So actually it might not be in this particular question. It looks like it is. It looks like it intersects the circle in one spot. But if it's a tangent line, it must be perpendicular to the radius. And if it's perpendicular to the radius, then that would mean that Pythagorean theorem would have to work. So let's just look at this triangle that I highlighted in yellow. It potentially might be a right triangle. This 8, XZ is 8, that's a radius. That means this little segment here is also 8. And they already told us that this was 5. So if it was a right angle, the right angle would be at X, and YZ would potentially be the hypotenuse. So 8 plus 5 is 13. So basically, I am testing out the Pythagorean theorem to see if the Pythagorean theorem works. If the Pythagorean theorem works, then yes, XY is a tangent line. If it doesn't work, then it's not a tangent line. And you can already see by looking ahead, 8 squared plus 10 squared plus 13 squared does not equal each other. I get 164 on the left and I get 139 on the right. So it is not a tangent line. The Pythagorean theorem does not work, so that is not a right triangle, so it's not perpendicular. If it's perpendicular, okay, if it's a tangent line, the tangent line must be perpendicular to the radius. Now in number 2, it's telling us it's a tangent line, so therefore that is a right angle. And they want me to find x. X is the hypotenuse. So this is a tangent, this is a radius. If it's a tangent, it must be perpendicular. Therefore, the Pythagorean theorem must work. So 9 squared plus 14 squared equals x squared. 81 plus 196 equals x squared. 277 equals x squared. So x is 16.6. Okay, question 3. Again, on these questions 3 and 4, it says assume all lines that appear to be tangent are tangent. So if it looks like it's tangent, it is a tangent. So therefore, this is a right triangle, and they want us to find x. X is this little piece right here. Now, I can do this one of two ways. This 24 is a side, this 32 is a side. This is x, and this is also 24. So I can use the x, and this hypotenuse then is x plus 24, but then I have to square it, and it does get a little messy. So another way to do this is to instead call the whole hypotenuse y. So look at my Pythagorean theorem. It would say 24 squared plus 32 squared equals y squared. Well, 24 squared and 32 squared is 1600 equals y squared, and the square root of 1600 is 40. So this whole hypotenuse is 40, but I just want to know x. This part is 24, so 40 minus 24 is 16. Okay, so it's much easier when this hypotenuse is two things. Otherwise, you're squaring that whole thing, and it does get a little bit messy in that you have to FOIL, and it just gets a little messy looking. So number 4, I'm also finding x. X is the side of this right triangle. Again, this is tangent and this is a diameter, so it must be perpendicular. The hypotenuse is 18. The radius is 7.1. It makes this 7.1 is also a radius. So this whole side right here is 14.2. So x squared plus 14.2 squared equals 18 squared. 14.2 squared is 201.64. I subtract that from 324 because that was what 18 squared is, and I get 122.36, and I take the square root of that and I get 11.1. 5 is another tangent and a radius, so therefore this is a right angle right here, and this one is similar to question 4, but I did do it the longer way just so you can see. So if this is x, this is also a radius is x. The whole hypotenuse is x plus 6. So look what happens. You have x squared plus 12 squared equals x plus 6 squared. This x plus 6 squared is really x plus 6 times x plus 6. That gives me x squared plus 12x plus 36 because you do need to FOIL it out. Okay, so that part's a little messy. The x squareds wind up canceling out, so it's no big deal. I subtract 36 and I get 108. I divide by 12 and that should say x equals 9. So my answer is 9. Number 6 is my hat theorem. Remember, if I have two tangents that meet at an external point, those two tangents are going to be equal to each other. So xw is equal to xy. These two segments right here are equal. So this segment right here and this segment right here are congruent to each other. So all I'm doing is setting them equal to each other. Just mark them equal. So 7x minus 29 equals 2x plus 16. I subtract 2x from the left and I get 5x. I add 29 to the right and I get 45. And I divide by 5 because I am solving for x and I get x equals 45. 5x equals 45, so x equals 9. 7 is the hat theorem also, in that these two tangent lines, all the tangent lines, I colored them, I highlighted them. So these two tangent lines are equal. The two yellow tangent lines are equal. The two blue tangent lines are equal, and the two pink tangent lines are equal to each other. So let's look at what they told me in the problem. They told me that this was 17. That makes this line 17 also. The whole line AB was 29. Well, 29 minus 17 is 12. So if this is 12, that makes this other side over here 12. They told me this was 2.5. That makes this little blue line 2.5 because those tangents are equal. And once I knew this was 17 right here, the whole side was 21. 21 minus 17 is 4. So if this pink line is 4, then that pink line is 4. So to find the perimeter of ABCD, I'm adding up all the sides. So this whole side is 29. This is 12 plus 2.5 plus 2.5 plus 4, and then this whole side is 21. And that all of those sides together are 71. And number 8 is the last one. Let's see, I have these two green lines are tangent lines, so they are going to be equal to each other. So that's the first part of the problem. Again, the two tangent lines are, if anytime you have two tangent lines that meet at an external point, those two tangent lines are equal to each other. So here they are. I have 13x minus 16 and 4x plus 11. So I set them equal to each other and solve for x. I subtract 4x and I get 9x. I add 16 to the right and I get 27. Divide by 9, x is 3. Now, once I know x is 3, I'm going to substitute it in. 4 times 3 plus 11 is 23. And I did that down here as well. So now I know this side is 23. The problem wants me to find FD. So FD is this. I'm going to highlight the line in pink right here. So FD is this line right here. So in order to do that, remember, a tangent and a radius are perpendicular. They form a right angle. I'm going to use the Pythagorean theorem. So 12 squared plus 23 squared equals FD squared. I just called FDX. 12 squared is 144. 23 squared is 529. 144 and 529 is 673 equals x squared. So FD is the square root of 673, and to the nearest tenth, that would be 25.9. Okay, and those are the answers to the lesson 5 homework.